February 22nd, 9:55 a.m. This is a normal Wednesday, and as usual, Ahmed, Cole, Jalen, and I are making our way to the engineering hall to attend the ISyE191 lecture. As we enter our class in our usual seats, Professor Amanda Smith greets and says hi to the class, and proceeds to say that today we are going to talk about another ISyE focus area, which is human factors engineering, and then proceeds to welcome Professor John Lee. Professor John Lee does research in cognitive engineering with a focus on human automation interaction. During the lecture, he talked about his lab team and his book, The Popular Introduction to Human Factors Engineering, which we are all excited to study. And then he continues with his lecture and mentions very briefly that he likes to cycle, and then talks about an extremely dangerous intersection. It is where John Nolan Drive and Blair, East Wilson and Williamson Street meet, and says that it would be great if some students went out there to collect some data and ultimately try to make the city of Madison do something about it. And boom, it hits us. Well, this class has a final project, right? The intersection is not going to fix itself. So we thought about the following research question. How can human factors engineering principles be used to optimize intersection design and reduce the risk of accidents at the meeting of John Nolan Drive and Blair, East Wilson and Williamson Street? And in order to get more information about this, we decided that we should try to set up a meeting with Professor John Lee. And before we even got to email him, I was in one of the Human Factors and Ergonomic Society Coffee and Donuts meetings, where I fortunately found Professor John Lee sitting there. So I took my chances and asked him questions about the intersection. And he was extremely nice, incredibly helpful to me, gave me some advice on what to look for and what to research about. And of course, I took some notes on the road designs he mentioned, specifically in the Netherlands, and the concept of stroads. So I thanked him for his time and decided to take a bus and look at the intersection myself. But wait a second. Concrete news is on. Oh, I'm sorry. We got to watch this.
UW-Madison's ISyE191 undergraduate student group, named Concrete, is interviewing strangers at the cross-section of John Nolan Drive and Blair, also known as the Hairball intersection.
I would describe it as harrowing. Chaotic, adventurous every time. I hope I make it.
Alright, as you can see, we're like literally in the middle. You can feel like what's happening right now.
Yeah. Okay.
Just something. Thank you very much. I don't take too much of your time.
No, you're good.
Thank you very much.
Most confusing intersection in Madison.
Probably the most dangerous.
Bad for all users, cars, bikes, pedestrians.
My GPS got me most of the way here, but once I got within like a half a mile or a mile or so, probably had to do about 3 or 4 U-turns.
It's rough. It's hard to get around. I'm still figuring out like when I'm on my bike, which way do I need to go to get over there, and having to go around.
You have to look a million different ways before you make your turn.
Okay, special thanks to Nasser and Concrete News for the coverage and interviews of the public. Now, let's move on to the research phase and the history of the intersection. Well, unfortunately, the only information we have about this intersection are from 2011 to 2015 from the City of Madison's official website. So, this is what we found out. The city did a study that found that 92 crashes were reported between 2011 and 2015 alone. 46 of those crashes were rear-end collisions. 9 were bike crashes, which is our area of interest. And here is a graph showing the locations of the bike crashes. The city of Madison has to start thinking about the fact that assuming people are going to drive everywhere is not going to work for a city built on isthmus. We have to start prioritizing transit, walking, and biking for short trips. You know, sometimes you have to give them the right problem to solve. And the right problem to solve here is not how to get more cars through intersection. It is how to make it safer for people who aren't in cars.
All right, thank you, Ahmed, for the great research and valuable information. Now, our investigation revolves around human factors engineering. But before diving into our solutions and how we applied human factors engineering, we'd like to take a moment to briefly clarify what human factors engineering actually is. HFE is a field that focuses on understanding the interaction between humans and the systems or products they use. The goal of HFE is to optimize the performance, safety, comfort, and user satisfaction of systems by designing them to be compatible with human capabilities. An example of this is one Professor John Lee gave during the lecture, which is the Norman door, or a door where the design tells you to do the opposite of what you're actually supposed to do. Now, looking at this image, would you push or pull this door? You would not know. So, as a HFE solution, we have these doors. In the mechanical engineering building, you'll find doors where it's very clear that what you are supposed to do. If there are no handles like this one, you cannot even pull, so the only option is to push, and if there is a handle, you pull like this one. In essence, this illustrates HFE in a nutshell.
All right, now that we have done our research, established that there is a problem, got a good grasp of what human factors engineering is all about, it is time to come up with a solution. One of the most frustrating things you can encounter as a pedestrian is a signal that does not give you enough time to cross the street, leaving you stranded in the middle of the intersection. Take these examples of people I filmed during my visit to the intersection. So it makes sense that pedestrians in the US tend to be opposed to multi-stage crossings. But leaving you stranded in the middle of the street is not an intrinsic characteristic of multi-stage crossings. What they actually do is to provide more flexibility in the signal timings. It just so happens that some traffic departments take advantage of that flexibility to simply reduce the duration of pedestrian phases without accommodating the walking speed of pedestrians. But it is also possible to use multi-stage crossings to improve the level of service for pedestrians. And that is what I'd like to show in my solution. First of all, if you compare two intersections with identical green durations, the one with two-stage crossings will have lower pedestrian delay. If someone starts crossing at the beginning of the green, they'll make it across in one go in either case, since both scenarios have the same total phase duration. However, if someone arrives later in the green, they likely won't be able to enter the intersection with a single-stage crossing. But with a two-stage crossing, they could at least make it halfway across. Then when the light turns green again, they're already halfway across the intersection. But this is a simple example. For a more applicable example, we head to the Netherlands, where basically every pedestrian crossing has multiple stages. Typically, each crossing has two signalized stages. Now, the fundamental advantage of multi-stage crossings is that each crossing conflicts with fewer other traffic movements. This means that there can be more chances for it to get a walk sign. Take, for example, this intersection in Rotterdam with a lagging left turn phase on the perpendicular street. The first half of the crossing does not conflict with the left turns, so pedestrians can start crossing while the left turns are still going. And this is exactly what I want to see in our intersection. This is perfectly applicable in our situation. If there were only a single-stage crossing, which is the way multi-stage crossing is treated in our intersection, pedestrians would need to wait until the left turns were completely finished before even starting to cross. This same principle can also be applied to reduce the delay to other traffic without delaying pedestrians. So this should become this. Also, consider individuals with limited mobility, such as those using wheelchairs, crutches, or experiencing a limb, etc. In our improved design, they can take the time they need to reach the halfway point safely without having to fear for their lives for completing the entire crossing, or having to purposefully stop halfway, wait for another cycle to be done, so that the walk sign is on again. Now, to make it a little bit more clearer, look at this video I filmed when I was at the intersection. So people would wait at the area that I highlighted in green because the cross sign is off, although it is completely safe to cross. But some people, maybe from experience I'd say, know that it is in fact safe to cross even though the walk sign is off. Just like this example. This is technically illegal, but should be made legal. I couldn't find a specific policy for the city of Madison, but I did find this. In Toronto, Canada, the way that the traffic signal operations policy describes multi-stage crossings is pretty consistent with how they're used in Madison and in North America generally. It describes how multi-stage crossings can reduce the impact of pedestrian phases on other traffic, but does not describe how they could be used to reduce the impact of other traffic on pedestrians. Pedestrians are very important to the city of Madison, so given how North American multi-stage crossings have historically been implemented in a pedestrian-unfriendly way, it makes sense that the city's policy is to use single-stage crossings as much as possible. However, the Dutch experience shows us that the multi-stage crossings don't have to be bad for pedestrians. If the city of Madison explored how multi-stage crossings could be used to introduce protected turning phases without increasing pedestrian delay, they might just adopt the opposite policy.
Now, as we draw our video to a close, we want to take the moment to emphasize that we've made a concerted effort to contact the City of Madison through their official website. Our goal is to express our concerns and hopefully prompt them to consider our suggestions for enhancing the safety, efficiency, and overall comfort of this intersection. We genuinely believe that by addressing this issue, we can create a better experience for everyone who navigates this area. Throughout our project, we've had the pleasure of collaborating with some truly inspiring individuals. We want to express our deepest gratitude to Amanda Smith for a fantastic semester full of learning and growth. We'd also like to thank Professor John for his invaluable guidance and for giving us the opportunity to engage in a thought-provoking conversation with him. As we wrap up, let's all hope that the City of Madison hears us out and takes the necessary steps to address the concerns we've outlined in our video. Together, we can make a difference and contribute to the creation of a safer, more efficient, and user-friendly environment from everyone. Thank you for watching and for joining us on this journey. Concrete out.